mysterious zone far out in our solar system. It's a region of ice worlds, some solitary, some with moons. Their names may be unfamiliar. Eris, Makemake, Haumea, but they hold clues to all our origins. And the first of these worlds, and the one we'll reach in 2015, is the king of the Kuiper Belt, Pluto. The long journey of NASA's New Horizons mission began in 2006 aboard America's biggest, baddest rocket, tricked out with every conceivable booster.
We built a very light spacecraft and bought a very large launch vehicle, and the combination is ferocious.
But in some sense, it all began in 1930 with Clyde Tombaugh, 24 years old and fresh off a farm in Kansas, but willing to spend long hours scanning star fields to find a moving point of light. Humanity's first glimpse of Pluto. The dream of actually getting to Pluto began with a 6-year-old boy in love with science, who grew up to lead a team of brilliant researchers and engineers with dogged persistence through decades of planning and building and testing. A race against time just to get to the launch pad.
Exploring the outer solar system, because it's so far, takes a lot of time. It requires a lot of patience, a lot of dedication, a lot of perseverance, but it's the frontier.
Assuming all goes well at Pluto, NASA may choose to extend the adventure further out into the Kuiper Belt, the solar system's mysterious third zone.
This is maybe the one chance in my lifetime that we're going to get a spacecraft out there and look up close at one of these Kuiper Belt objects.
December 6, 2014.
We have long to wake up with the New Horizons spacecraft.
New Horizons wakes up for the last time from hibernation.
New Horizons is speeding towards Pluto at a phenomenal rate, and we can't wait for it to get there.
January 27, 2015, 6 months of approach science begins. July 14, 2015, New Horizons' long journey, 3 billion miles, 9 years in flight, and 85 years of speculation about Pluto, climaxes in one day of close approach and flyby.
You know, we're rounding third base and we're headed home.
The dream, the adventure, the promise of discovery. That's what makes 2015 the year of Pluto. Studying Pluto and its neighbors from Earth is one of the toughest challenges in astronomy. It takes the largest telescopes and most advanced instrumentation on the planet. And it's tough even for the Hubble Space Telescope. And it takes time, from the discovery of Pluto in 1930 to NASA approving the New Horizons mission in 2001 to arriving at the planet in 2015. It's been 85 years, and time passing is definitely an actor in our story. But it's the combination of human skill, cutting-edge image processing, and sheer bloody-minded persistence that has resulted in the most important discoveries. And that's a tale as true today as back in 1930, when Pluto was first found by Clyde Tombaugh. In 2011, at the SETI Institute near San Francisco, Mark Showalter used Hubble data to discover 2 new moons around Pluto, although he was actually looking for possible rings. Showalter has found rings associated with small moons around other planets.
And that was kind of the motivation for checking out Pluto. It's got 2 little satellites. Satellites raise clouds of dust. Let's see what might be there.
It's easy to take artistic license to show what Pluto's rings might look like. In reality, it's incredibly hard to see faint objects against the dense background star field and the glare from Pluto and its large moon, Charon.
We came up with this trick where you take the images and then you rotate the camera 90 degrees, you take more images, and if you do that all just right, you can do this thing where all that glare cancels out, and what we're left with is just the rings. We can think of it as a stack of images. Think of it as like a cube looking down. So let's turn it on its side. So now if we start peeling off the layers and looking downward through the stack, things suddenly become much, much cleaner. For example, Hydra and Nix show up very, very cleanly. But the thing that immediately caught my eye was this little dot right there. It's not a perfectly sharp hot pixel like over here, and that's what made it pretty convincing to me that we had seen a very small moon of Pluto that nobody had seen before.
To be sure you've detected a real moon or planet, you have to show it's moving, unlike the background stars.
The thing that makes moons distinctive is if we come back later, they'd all have shifted because they all orbit the central planet. This required a great deal of patience to then wait about 6 days until we got our next set of observations of the Pluto system. Sure enough, the object was still there. It had moved by just about the right amount to be something orbiting Pluto, and we knew we had a moon.
Next year, Showalter and colleagues went back and built on lessons learned to see what else might be there. Summer 2012. Now, Mark had 15 more days of Hubble observations.
Now, what you can see here are 3 time steps. Each of those time steps is actually about 45 minutes of data. That means it's long enough that the little moons move. It's moving back and forth in this 3-frame sequence. Hydra is moving, Nix is moving. I mean, it doesn't take a rocket scientist to say that that looks like a little moon of Pluto. It's moving just the way the others are. They're all going around the planet in the same direction. And so it was just a couple of weeks later that we made the announcement that the 5th moon had been discovered.
Patience, persistence, ingenuity. That was exactly what led to the discovery of Pluto back in 1930. In Kansas in the 1920s, Clyde Tombaugh grew up in hard times and built telescopes using leftover farm implements. To check the accuracy of his best telescope, he sent drawings of Mars and Jupiter to the Lowell Observatory in Flagstaff, Arizona. They were looking for staff, and he was hired. Along with observing the stars, he stoked the furnace and shoveled snow. But one assignment made history. Day after day, he'd use this machine, known as a blink comparator, to look for anything in his images that moved. It was tedious, painstaking work, but on plates taken on January 23rd and 29th and analyzed in February, he saw a small dot that did move against the fixed stars. Announcing the results after careful confirmation, the observatory made it easy to find the new planet by adding arrows.
This is an incredible work of observational astronomy, and having done something similar but with much more powerful tools, I can really appreciate his achievement.